Hello.
Hello, everyone. Welcome to the first ever live episode of The Boring Show. My name is Craig LeBenz.
And I'm Khanh.
And we're excited to be here today for the first time ever, coming to you live. And it's going to be a continuation of last week's Observable Flutter episode, where I began to attempt the Doodle Dash Challenge.
The Doodle Dash Challenge.
Yeah, which is of Khan's creation. And for those who maybe aren't familiar or weren't able to see that episode of Observable Flutter, we'll kind of catch you up from the beginning. But Khanh and other members of the Flutter DevRel team, including Eric Windmill, made an entire video game. It's a Flutter themed port, would you say?
Port?
Kind of
inspired?
Yeah.
Doodle Jump inspired game?
Yeah, of Doodle Jump. So it's called Doodle Dash because Dash and Sparky of Firebase are the main characters. And I have it running here, though it actually, this build of the game comes with the features that we added last week. So let me just quickly restart here. And I'll dive in and we'll open as Dash. I'm going to try to alternate as we go today. So this is the game that Khanh and Eric and others, but I think primarily you two, made. And so you're Dash or Sparky, and you just kind of jump up forever. And I think I still have the cheat on. Yeah, so I can just fly,
you do.
Which is great.
It's great. I got so many high scores doing that.
Right. And so last week I added these UFOs that shoot lasers at Dash, and they go at irregular speeds because of a hastily decided random speed function that really doesn't work very well. Well, I mean, it does work. You get random speeds, including ones very close to zero. So we're going to continue this effort. Oh, actually, that screen right there was pretty funny. You could see the lasers going at different speeds. That's what we're going to continue today. So there's a couple little gotchas, couple things don't work that well in that particular you can see there a laser just passed through Dash, and Dash is, unaffected by it, none the wiser. So we don't have collision detection or anything. Khanh, any thoughts before we dive in?
Not particularly. I'm super excited to see these lasers. I mean, watching it, coded up live on Observable Flutter was super awesome. So I'm excited to see it. And I see comments already coming in for us. So hi, everyone. Everyone's saying hi. We can't say hi to everyone, but hi, everyone.
Yeah, I can't see the comments too much or really at all. They're a tiny bit on Khan's screen here, but she'll alert me to anything that we need to get to.
Will do.
All right, we've got a real flurry of laser beams here, which is pretty fun. I like that we've landed on a spot where there's a platform just off screen.
It's still bouncing.
So Dash is just kind of bouncing there. But I think maybe bouncing lower and lower, we might be working. Oh no, that was a higher bounce. Is there like a random height effect on bouncing?
There should not be. I believe it should be the same.
Dash is not jumping the same height every time here.
That is very interesting.
Well, QAing games is a whole nother effort.
Yes. Yes, Dash is jumping higher now. I can see the difference now.
And sometimes she only jumps to like here, like that one.
Yeah.
Huh.
Well,
Khanh, it's almost like this was a really, Herculean effort the two of you just did. It's almost like you didn't have a QA team.
Yeah. What QA team?
What a shame. All right. Well, this is looking really quite funny here. But shall we begin?
Let's go ahead.
Okay. So one of the things that we had in the last episode was some viewers observed, and they eventually got me to notice as well, that when the lasers are moving from the right to the left of the screen, they actually just fly backwards. And that is apparently because of the limitations of the trig code that I wrote with the help of chat last week. So I'm now going to lose the game. We're going to fly up on the left side here, and I'm just going to cheat. And as soon as, wow, look at all these lasers that are already there. What? Anyway, as soon as there's one, we can see kind of shooting across the screen there. If they move from the right to the left, they point. backwards due to the limitation of the inverse tangent function
Inverse tangent.
that we settled on last week. So that is where we'll begin. And you can see I've not even saved the code that we wrote last week. I still have my git stat or my git diff indicators here. So I played around with this a little bit over breakfast today because I didn't want to have a whole nother math class on stream. And I have a solution. I'm happy to report was like the second or third thing that I tried. Was not the first thing that I tried. It also is probably not the best thing, but it seemed to work. So if we look at this code here, actually, should we begin by having a little tour of the code that we added?
Yes,
I think we should.
Yeah, I think that would be good for those of you who are tuning in and didn't get a chance to catch Observable Flutter.
Right.
Because I also had to miss the last part of your stream last week. So.
What, do you have a job?
What's that?
So in this, there's an object manager class. I think we'll start there. This object manager class is responsible for kind of peppering the world with objects, the platforms, whatever else. Actually, why am I even explaining this? Khanh, tell me what the object manager class does.
Yes, the object manager is responsible for spawning objects in your game. So that's going to be primarily the platforms, enemies, and power-ups as well.
And this is, so it's a flame object here, right? It extends component. It has game ref, all this good stuff that you see if you play with flame. And it has its on, on mount and on update methods. And the update method is, of course, called every tick of the game. And, just like how there are some widgets that don't actually draw anything to the screen, but they just kind of have this orchestration role. Stateful widgets often will do this, where it's like, my job is to just keep track of this one flag, and I don't actually render anything. Well, it turns out actually components in Flame can kind of do the same thing. So the object manager, it doesn't render anything, right?
No,
it just adds things to the game. It adds
things. Yep. It's sort of there as, well, managing the objects.
Right. Yeah. That's what it says on the tin. And so in that last episode where I started this effort, I kind of focused in on this update method of the object manager, which is where every tick as Dash or Sparky are climbing through the cosmos, this method is called, and it decides, does the universe need more junk? And if it does, then this condition, this condition is what Khanh and Eric decided means the universe needs more junk. So this condition resolves to true, and we get in here. And so I just added some code to start to sprinkle the universe with aliens. We're going to solve Fermi's paradox. We're not alone. That's the answer. But Khanh, could you maybe tell us a little bit about this conditional? Because I, was pretty sure it was going to be reasonable to put my new add a UFO code in this if statement. But I'd like to hear from your fully in the code base perspective. Like, talk me through this.
Yes. So I think the idea with this code here was that if the top of that lowest, so I guess we have to talk about the axes in the game, right? So 0, 0 is that top left.
Top left. Yeah.
So if the lowest platform is beyond the bottom of the screen, so it's a larger number than the bottom of the screen, then you'll just generate the next one.
So lowest in this perspective is from the player's
perspective. Yes, that's correct.
Got it. Okay. So the lowest platform is higher than the screen bottom. So I see. Okay. Well, it seems more reasonable now that you've just talked me through it, but this basically means, and then because you're cleaning up platforms.
Yes. Yep.
Right.
Yep. You don't need those anymore. So
they eventually make their way to the garbage disposal.
Yep.
Yeah. Okay. And then I had somehow just kind of assumed this was running, even though it's just obviously not what the code says. I had assumed it was something about the top platform, like approaching or something.
I see. Okay. Yeah.
This literally says screen bottom. So I don't know why I thought that. Okay. But anyway, so we get into this if statement, and then with 20% probability, so basically there should be one UFO for every 5 platforms, something like that, we might expect. Then we generate a new UFO at a certain position. And this add method is kind of a magic method provided by Flame that, it says like, hey, UFO, get in the game. and it starts rendering itself and doing stuff. So any thoughts, any comments you want to make on that code?
Not particularly, just that I really love that add is something that exists in Flame, because when I first started, I've never done game dev before. So I was like, oh no, how do I show things to the screen? Like, what do I do? Oh, just call add in your component. That's it.
Yeah, it kind of has that same level of magic as like set state.
Yes.
Yeah.
Craig, I'm just going to pause for a moment here. I see there's a comment asking about the Flutter roadmap. So I'm going to show this. And I was just going to say, tune into Flutter Forward. I mean, this is part of the 17 Days of Flutter campaign. But next week, Flutter Forward, I think we'll have a lot in store for you. I think you'll be excited to see that. So.
Yeah, great thought to flag that. The name of the event, Flutter Forward, is not just an alliteration. It's where Flutter is looking forward. It's the future of Flutter. So
we're looking forward to it.
Also, the roadmap of Flutter is always published. Tim Sneath, one of the head directors, whatever, of Flutter, annually publishes the roadmap for Flutter. And I don't know where that is off the top of my head, but if you Google Flutter roadmap, you will see the last version that was published. But good question.
There you go.
Anything else that you think makes sense to get to right now before we start writing more bugs?
I think we're okay. Let's see. Randall, I see there's a comment here.
Oh, hi, Randall. Do you want to read it?
Oh, yeah. Using offset from direction and dx and dy in direction and distance are a great simple way to do polar conversions and calculations. Oh, that's a good call out. That's a good tip.
Offset from direction in dx dy.
So instead of having to calculate that manually, we can use the offset, right?
Do you know what he's referencing here in terms of
I think when we were talking about I think when we were talking about the from where the origin is, if the number is greater or less than, like, so at the top of lowest platform is greater than screen bottom. So if we just calculate an offset instead of
direction dx dy.
So then we use.
Oh, interesting.
Yeah.
I'm not gonna lie, Randall, I'm properly intimidated by polar coordinates. And the only conversion that I want to do about polar coordinates is converting myself right away from them to not worry about them at all.
Joke counter.
Yeah, take it.
We were talking about a bad joke counter before we started rolling, so it's we're in competition. Who can make the most bad jokes? Unfortunately, I think I burned one off camera. So.
Okay, are we ready? Oh no, there's a little more to cover. So then, in the platform class, where there's all kinds of stuff about different things that Dash can land on and jump off of, all kind of originating from this abstract platform class. And actually, I don't think this code should have gone in this file because, I did end up extending platform, even though Dash or Sparky cannot interact with the UFO itself, just the lasers they shoot is our goal. But in here, I added this UFO class, and the lights kind of twinkle on and off, which is just a little visual effect, quite subtle. You can miss it when you're looking right at it. But in the update method, so again, Flame calls the update method of like everything in the game, every tick of the game. And so every UFO basically gets a chance every frame. So ideally, 60 times per second. Like, hey, you got anything you want to do? You got anything you want to do? You got anything you want to do? And with 1% probability, every UFO will decide, I think I'll fire a laser at Dash or Sparky. And so this is the code that does that. And if you watched the last episode, you saw me draw some, childish looking triangles as I tried to solve basic, 9th grade math questions.
I may or may not have taken a picture of you doing that and posted it to Twitter. So.
Oh boy. With apologies to all my old math teachers. But we settled on this code. So the game's position, the player's position. So this is, Dash or Sparky, minus the position of the UFO. That creates a vector that is kind of where the laser needs to go. So that takes us from the UFO's position to Dash. And we decided the laser is not going to track Dash. Dash is immediately moving. It's not trying to lead them. It's just a very naive shot. But the laser is then going to be heading toward Dash. And the other thing that we needed to do was actually angle the laser so it looks like it's heading toward Dash. So, if it needs to fly in this direction, we don't want it to like do this and just look real silly, right? So we always want the laser pointed where it's going. And so this angle parameter on the sprite class in Flame applies any rotation that you need. It's kind of like a transform if you're familiar with that widget in vanilla Flutter. And so this was the trig that we did on stream. Major thanks to chat. I think I would still be just kind of staring at it going, what? But we landed on this, and it's great until the laser needs to go right to left. So now I think we're caught up.
All right. Cool. And I have to say, I'm genuinely impressed that you were able to do all of this trig and on a live stream, because I was reading the chat and I was like, wait, folks, y'all remember all these things. That was very impressive.
I was also impressed that you all were able to do this trig because I simply wasn't. Especially the tangent to inverse tangent tip. That came from chat, and it was so welcomed. Okay, so this is the little bit of research that I did over breakfast this morning. And I was just thinking, if the laser looks incorrect, it's pointed the wrong direction when it's going right to left. Well, that's a matter of the x-axis value of our vector. So I thought, well, we can probably write a conditional on the x value of the laser's vector. So I tested, and this again was like the third thing I tested. Vector.x, if that's greater than 0, then we're going left to right. So that is the code that we had written and that works. But if it's not greater than 0, then we have, then we're in our problem state. And I said, well, what if we just took this exact same code and we subtracted pi radians from the direction of the laser? Because again, there's 2 pi radians in a circle. So pi radians would be 180 degrees. So I said, let's just subtract 14159 from the result here. Let the formatter do its thing. And there might be other edge cases that I have yet to bump into. We'll find out. Give Sparky a go here. But I think this kind of just works. So let's get, oh yeah, I can cheat. So look at the lasers are going the correct direction, and they should go the correct direction when they're going up as well. We saw them in the correct direction going down.
Down.
Somebody shoot at us, please. Fire your weapons. Okay, here we go. We're going to just kind of hang out. Oh my God. Someone shoot, please. There we go. We saw one briefly. It was pointed the right direction. So I think we've solved our laser issue. Please shoot. It's really actually tricky to just stay where you are,
Yes. Getting screenshots of the game was a lot of fun when we were working in the code lab.
Just how quickly can you press the button?
We ended up just doing screencast recording and then just taking a screenshot
of that. Right. Smart. Well, we saw it briefly. We didn't see it for long, but I think we saw it work. So people who actually know triangles and math might be just pulling their hair out at the silliness of what I've written here. There's maybe like one negative sign I can put somewhere and it would simplify the whole thing, but I don't know what that trick would be. So this is what we got. And I think we're ready to move forward.
All right, let's move forward.
All right.
Is collision detection next?
Well, I think it certainly could be. Also, do we have any questions in chat we want to get to?
I wanted to highlight this one here. So Marcus asked, well, what VS Code theme is that, Craig?
Great question, which I get regularly. And I'm beginning to develop a pride around this as if I designed the theme, which I certainly didn't.
Although I remember when you found the theme, you were very excited about it because
Yes.
we sit next to each other.
Yes.
So he was very excited when he found this theme.
My best, one of my very dearest friends put me onto this theme, and I thank him mentally every day. And it's called Synthwave 84, and it's just wonderful. Matt, if you're listening, which you're not, because you also have a job, really appreciate it.
Cool.
All right.
That's it.
That's it for now?
Yeah, that's it for now.
Okay.
We'll keep going.
So collision detection. There's a lot of examples of collision detection already in the code base. So why don't we start by just looking at one of those? For example, right, Dash, whenever she collides with a platform, needs to jump. So we already know there's going to be code to see if two things are bumping into each other. And I imagine there's a bit we can just see right on the abstract platform class. So Khanh, you wrote a lot of this. Why don't you talk us through it, and I'll focus on what you're talking about.
Yep. Yeah. So for platforms, it has that collision callbacks mix in. So anything that extends platform will already have those collision callbacks available. So there are kind of two ways that you can approach this. So when Dash collides with, say, for example, a platform, the platform can have a callback, but Dash can also have a callback as well. So that's where you'll want to decide, okay, well, what does Dash do? Or like, do you want to call, because you have a reference to that other object that you've collided with, you can call, for example, like for Dash, it's like, oh, you can check, is the other thing a platform, a normal platform? Okay, then let's jump. So in this case, I'm assuming what would happen is when Dash collides with, one of the laser beams, I don't know what happens to Dash. Did she become the Hulk, or is that an enemy?
I had imagined it was an enemy.
Yeah. So it could be, different colored lasers, and then you can make it an enemy and a power up. But then maybe we'll stay with making the lasers an enemy for now.
Yeah. I think different kinds of lasers that do different things seem like a very fun idea. Maybe we'll have time to get to, but also, even if we don't, great fodder potentially for your own Doodle Dash challenge entries. So yeah, you add this collision callbacks mix-in, which comes from Flame.
Yep.
Right. And then you need to add this hitbox as well.
Yes.
Right. If you don't add the hitbox, it doesn't work.
Yes.
Right. And the hitbox, it's as simple as it looks here, right? This rectangle hitbox, this is also from Flame.
Yes, you'll have to add the hitbox though. So if you scroll down to up right there. So in onload, you'll see await add hitbox, and that's essentially it. That's all you need to do, and it's already been done for you within the platform superclass, so you don't really have to to deal with it. You already have a hitbox, so you can just go ahead and overload the on collision.
Right. Okay. So there's no on collision overridden on the abstract platform class itself.
Yep.
Because it's abstract. So it's not going to have any opinion about what happens when
it does not care.
Right. When one of its inheritors collides with something. But let's find an on collision override. I saw one a second ago. Here we go. So we are currently in the springboard on collision method. So let's look at what this is doing. The intersection points. I have a guess as to what this is. Did you ever fully point your brain at this parameter when you were writing the game?
Yes. So I will have to credit Eric for that. He did a lot of like the research and like setting up on that. So I just jumped in. I was like, okay, let's see what Eric's already done, and let's kind of copy off of him here. So essentially the intersection points is where the collision is happening.
Yeah. So
right,
like the clip.
Yeah.
Would it be? The set of pixels that are overlapping.
Yes.
Is it kind of like the top left of the overlap to the bottom right of the overlap?
That's a very good point. Yeah, I haven't.
That's my guess.
Yeah. Because when we do the calculation here, so if it is colliding vertically, so that's how we check if it's colliding vertically, right? So it's the first intersection point, like the y coordinate, and then the last y coordinate.
Right.
So if it's greater than or less than a certain value, then you know it's colliding vertically because if you subtract it.
Got it.
There, because again, the origin is a larger number than the further below.
Lines of code like this, I feel, are just such little brain benders. they're so hard to like think about and kind of figure out what on earth do you write here. I often will literally have to draw things out like I did last week. You know, and even just in looking at this and trying to reason like, oh, did they write this correctly? Like if I was doing code review, I don't know. Obviously the game works, so you wrote it correctly, but man, you know, lines like this are just very tricky.
They are indeed.
But
once you have it, it's easy to use though.
Right. Once you have it, you're good to go. So yeah, is colliding vertically. Great. Variable name definitely reduces any pressure for a comment. And then we kind of see, okay, so the platform just kind of visually reacts to being hit because it's kind of like a little trampoline. So this is collision detection. Now this is obviously kind of a passive bit of collision detection. What's happening is just a little vertical or
it's just a
visual.
Yeah, the visual change in the sprite that's being displayed for the trampoline.
But let's look at maybe the collision detection from
that is a hefty callback. I will say that one was if you've gone through the code lab, you've seen like you just continually keep adding to on collision in player.dart. Like I think maybe we have 8-9 steps and about 4 of them reference on collision for player.dart because you add to it iteratively and you kind of add to it logically by way of like, oh, which what are you adding to the game and why, but you don't add it all at once. So
gotcha. So so yeah, there's just all different kinds of things here, right? If you hit an enemy platform, so this seems like something that we might reference here, because we're about to be treating our lasers as enemy platforms. We're not going to inherit from enemy platform. Certainly, we're not going to actually use this code, but I might copy it, paste it later. Yeah, so we've got Khanh. Yeah, I remember you talked about when Dash gets certain power-ups, she moves too fast to make dodging the enemies possible.
Yes.
So you're briefly invincible.
Yes.
There it is.
Yeah, I mean, when you're in a rocket, you have to be invincible, right?
Yeah.
What beats a rocket?
Well, certainly not a platform.
Okay.
Actually, I think if you flew a rocket into a platform, you'd have a really bad day.
What if it was a paper platform?
Then you'd probably have a good day. So yeah, more checking here. And then we start to see, okay, is Dash moving down? Are we colliding vertically? Similar check that we had a second ago. And then figure out like, all right, what kind of platform is it? And then jump appropriately. So springboards get a fancier jump. Broken platforms jump, but you break the other platform. That looks great. I
wanted to call out here like the other reference that you get.
Oh, yeah.
So that's I think one of the really cool parts. I was very excited about with playing because you just get a reference to the other thing that you've hit, and then you can just decide, oh, what kind of object is it? What do you want to do with it? And then you're basically done.
Right. So yeah, incredible. So that comes in, and then this, as you were talking about here, this is where we're checking what the heck is Dash or Sparky bumping into here. And then more power-ups. Oh my goodness. Yeah, this really is pretty involved here. What does this section do?
Yeah, so this is the power-up section of the game. So if this one makes sure, first of all, Dash doesn't have a power-up because Dash can't have 2 power-ups at the same time, at least in the game that we jumped up. If y'all want to, make sure that Dash can have, all the stack up on power-ups, that's totally good. You can, remix the code here. But so if Dash doesn't already have a power-up and the other thing that the sprite that it runs into is a rocket, then Dash becomes the rocket and then just jumps, flies up, zips. I don't think jump is the right word there. It's just Dash flies up through outer space. And then the other case is Dash doesn't have power up and, she runs into a nuclear hat, in which case switch the Dash's sprite to the nuclear hat sprite, depending on which direction the current sprite is looking. And the other thing I'll call out is other dot removed from parent. So for example, here, when Dash touches, one of the nuclear hat sprites or the rocket sprite, you want it to disappear from the screen because if Dash has already taken the power up, it's one of those things where, we could leave it on the screen, but it just makes it look a little bit more polished by just removing it
Yeah.
from the screen totally.
No, absolutely. Especially with the Noogler hat, it really looks like Dash kind of puts the hat on.
Puts the hat on. Yeah.
If the hat stayed there,
Yeah.
like, what just happened?
You know, we want it to look a little realistic.
Give me one of those hats. I need to inspect this. How do you work?
Not working as intended.
Right. You clone yourself when hit.
Oh,
Nice.
hey,
Yeah.
Simon. Simon says, "Hi, Craig and Con."
Hi, Simon.
Hi, Simon.
Glad to have you joining us in your evening.
And I'm excited to finally get to meet you in person in London. We're doing Flutter Forward Extended in London.
We're going to London after.
Yes, after Forward.
After Flutter Forward. Nice. All right. So we've kind of seen a bit of collision detection with Flame. And I think it's time to override this method ourselves. So I'm just going to copy this from player and go back to platform where the UFO class awaits and add. We've got unload, update. I guess we'll go at the bottom for no real good reason. What are you upset about? Try adding behavior in the overriding method. Oh, indeed. Don't you love how the linter gets really upset at in progress lines of code? I was like, yeah, I'm working
complete lines of code every single time.
Yeah. That on keystroke latency, that really quick speed of linting is just
gotta love it.
99% of the time it's
saves
good.
My life. Yes.
1% of the time, like I'm literally in the middle of the thought. Okay, so at this moment, we know that a laser beam is hitting. No, we don't know that a laser beam is hitting Dash. We know that the laser beam is hitting something.
Something.
That's what we know. The laser beam is hitting something.
Yes.
So what we need to do is say if other is, and then what's the right class here? Is it called player?
Player.
Okay. So if other is a player,
what do you do?
When lines of code
just
sound funny, like
yes,
there's a player.
Yes.
So, but if the other is a player, which will never stop being amusing, then we just saw you had a way to kind of end the game. Do you think we should be so harsh? It'd be nice to have lives.
It would. Yes, that would be it. Do we have time to add it? We have to implement lives. We could just make it game over and then continue on and try to add lives.
I saw collision.
It should be on lose.
Oh. Okay. And then was there? You just returned. But okay, sure. Because we might have other stuff.
Yeah.
We probably won't. This will probably be it. Oh, it'd be fun. Oh, what if the lasers could like destroy anything they hit?
Oh, it could be an enemy or it could help. Oh. Well, but if it destroys the platform, then Dash will not be able to jump.
Yeah, that'd be bad. That could be kind of fun to play with, though.
Yeah, right, it'd be interesting.
Yeah, let's see if this works for now, and then I think maybe we can we should also get the velocity right, because remember some of those lasers were going unbelievably slowly. Okay, we're back here. We're back to Dash this time. Now let's go face plant right into a laser beam. Okay. Hey, we did it.
Oh, game over.
It's really
it's just done.
Yep.
One of the things that we didn't get around to, I think would be cool to work on is to have Dash react in some way to so right now when the game ends, when Dash falls below the screen, it just goes to the game over overlay. Right. But for example, when colliding with enemies and things like that, it'd be really cool to have, Dash, have an animated Dash spin or something with an X, or something in her eyes and just fall down.
Yeah.
I think Dash and Sparky would be really cute like that. I mean, personally.
Yeah.
That's clearly my goal with making this game. It was just I just want to work with cute versions, cute sprites of Dash.
I'm thinking about Sparky. Old Nintendo games where the Mario would like flash red and then just kind of fall out of the screen.
Yeah, and you can add some sound effects too.
Right. Which Flame has great support for. Though I don't think we have any sound effects in the game currently. Right?
No, that was on our to do in future sprints list. Yeah.
I think that will be a nice touch. But for now, we've already added collision detection. So Flame really, and the amount of work that Flame is doing to allow us to write this simple little bit of nothing is just incredible.
I had not really worked on a game before. We worked on Unity a little bit, and for our college project, we made checkers, I believe. Yeah,
Oh,
it was
nice.
a game of checkers, and that was the closest I'd ever come to a game
Making a
engine.
game,
So the
yeah.
fact that I was able to pick up Flame in a relatively short amount of time and put together, I think a pretty functional game was
Yeah,
that was
yeah.
super awesome, and I'm so excited about it.
Now, God, the tooltip, just the bane of my existence.
I think Danielle has a recommendation.
Oh, great.
But a platform should stop a laser.
Oh, I love
Oh.
that idea.
Yeah.
Yeah, that's so much better than the laser destroying the platform. Great idea.
Thanks,
This
Danielle.
is how you design games. You have like 100 people weigh in.
Yes.
There's no, a camel as a horse by committee analogy here, though that idea is a good one.
We should do choose your own adventure, but boring show edition, where it's just we'll have the audience pick what we're gonna do.
We're gonna have the boring show version of Bodie McBoatface in like a minute.
All right, cool.
That's what I think my favorite story in like the last 10 years of the internet is Bodie McBoatface. If you don't know it, look it up. Okay, so first of all, the lasers move at absolutely absurd speeds, absurdly slow sometimes. So we've got this laser class. This was also added last week in that Observable Flutter episode. So I'm going to pop over to the laser file, and there's not a ton going on here other than it moves itself in accordance with the vector that it receives, which it normalizes in the first place. So this velocity, I think the velocity was actually just picked in platform. The UFO set the velocity. Yeah, here it was.
Mm-hmm.
So this code is responsible for some extremely slow laser beams. And I was thinking about this in the afternoon after that last live stream, and I realized how it should have looked. And I think we basically just want to say ×3.
And then have the minimum there.
+1.
Yeah.
Yeah. So now instead of randomizing between 0 and 4, we're going to randomize between 1 and 4. So we're just chopping off those lower values. So I think now if we refresh, we're still going to have a heck of a time dodging these laser beams, but we shouldn't see any of them inching across the screen
slowly,
like dripping glass.
Although that's a good point. What if we introduced, a turtle or something to the screen where it slows dash down, slows their jump speed instead? So that could be an enemy.
Oh, like a non-fatal thing, but also
yes.
It's not a power up, it's power down.
Yes, yeah.
Oh, nasty.
I was thinking like the banana in Mario Kart. I always hated that when we played Mario Kart.
We need green turtle shells too.
that was okay. That was on. I'm not gonna lie, that was on the list, but we're like,
okay, so
we're gonna stay on theme.
The laser beam just caused me to lose because I couldn't get to the platform. Oh no, I could have. I needed to go off the other side.
Yeah, you have to go. Yeah.
My brain is not used to that at all. Oh, that was an unfortunate start. All right, let's see here. Ta-da, we're shooting up. Okay. Oh. We just lost from hitting. I wonder if that UFO had just fired.
You had just fired. Yeah, I think it had just fired. Like I saw the.
Oh, you did?
Yeah.
I didn't. All right, that's working pretty well. And now, what should we do next? Now we're really into like whatever sounds fun.
Yeah. So Nimesh had a recommendation here. Oh, I don't know Nintendo's Adventure Island, but when he jumps with a scare face and game ends, that would be cool to have Dash. Like again, like one of the have Dash animate and kind of change sprites when you lose. Yeah.
Well, we've only got like 20 more minutes.
Yes. So we've
got to move fast here. Let's get to a couple of these. I like the idea of the laser beam being blocked by a platform.
Yes.
So I think this is going to be incredibly easy. I'm going to take a stab
I'm always scared to say that when I'm coding, to be completely honest with you. Anytime I say something feels like it's going to be easy, it's going to be, and then that's always the one that gets me,
Yeah.
But I think, what were you thinking? Because I'm thinking if we just add an on collision, right?
Yeah.
On platform or on the laser itself, and
collision callbacks.
Yeah.
Yeah, absolutely. I mean, I think Flame is just gonna like classes can only mix-ins and classes. Feels like that's what I'm doing. Collision callbacks. What?
What is missing here? Hold on, let's see. I have
sprite component.
I had the code open. Let's see.
Slider. We're importing Flame. There's not like a special. Do you have to import Flame collisions?
Collisions.dart?
Oh, we have to actually import Flame / collisions. It doesn't come in natively from Flame.
Yeah.
Aha. I bet I could have command clicked and it would have just said it. Yep. Yep. The quick fix. If only there was a good decoding Flutter about those. So now we can do this dance again, and the laser can begin to collide with things. And here, I think we can just say, if the other is a platform, which it looks like need to import as well. I think we'll need to import, yeah. That will come from sprites.dart. So if the other is a platform, how do we remove ourselves?
We just call remove on.
Just remove?
Yeah. Remove from pair?
Okay. Remove from parent. And let's check it out. To test this, I'm going to briefly pop into the players. Now, where was it in laser collision detection? Wait a minute. Am I losing my mind here? I know why we died when we hit the UFO. I put the collision detection on the UFO.
Did you?
I think so. Because look at us add it to the laser here, and it's not there yet.
Oh!
I think I put it on the UFO. UFO. Oh, it's a platform. This is it. Yeah, collision detection.
Well.
There's your problem. So laser. Yeah, we said, and this doesn't have a game ref. Briefly. Has game ref for Doodle dash.
I see a few folks on chat mentioning that it's like midnight, 2 a.m. for y'all. Thank you for tuning in. And if y'all want to, go to sleep, please do. This boring show is recorded, so you can tune in later. But we really appreciate you being awake at that hour to watch us be boring.
Right. Yeah. Oh, gosh, really appreciate the effort. Also, we are apparently asleep at the switch, so you shouldn't feel bad if you fall asleep. So the UFOs are no longer a source of headaches. They're not a thing you can bump into anymore. Laser beams are. I think this is going to be way better. But actually, no, I want to comment out the losing part so we can just
you can actually just see if it's the platform. Yeah.
Yeah. So let's test that real quick. All right, restart again. This time I think we're Sparky. And let's go.
Lasers.
Laser. Okay, here we go. Oh, God, I couldn't stay. Where would I comment the code? How do I comment out gravity?
You could just remove the gravity. The gravity. It should be in the update.
What a UFO drought we just had there. Okay, so God. Oh no, they're not getting blocked. They're not. The laser beams are not going away when they hit a platform. Okay, this should be, look, it just went right through the platform. All right, so let's think about this.
Yes.
We did something wrong.
Other is platform. Laser down.
Okay. Dash. Oh yeah, I do want to comment out gravity. I think this also might be a helpful trick for everyone else as they add whatever features they come up with.
Yeah.
Oh, okay.
All right, let's see. Lasers.
For F's sake.
Do we see print statements?
No print statements. Yeah. All right. So let's just think about this.
Do you have a hitbox on the laser?
I didn't have a hitbox. No,
does it extend platform?
No.
Okay, that might be it.
Doesn't have a hitbox. You're absolutely right. And I think I saw you add it. You can create it here. So this would be final hitbox equals rectangle hitbox. And we don't need this. And then we simply add the hitbox.
Yes, and unload.
Thank you. I had that on my mental checklist and then didn't get to it.
I think live coding just does that.
So does dead coding. All right, let's go cheat our way into a quick test. We're getting print statements at least.
Oh gosh, I hit a platform.
I'd like to see it happen though. Fire your weapons.
Anything? Anything? It's Mueller.
These pacifist aliens again. All right, so this now makes me wonder, did we somehow remove like every laser?
Oh, because if you remove it,
These UFOs move in herds. They do move in herds. And then they just don't exist for a long time. Oh gosh. All right, we got to comment on gravity. Where do I do that?
You go to player.dart, and in the update method, there should be, go down right there. So if you just want to get rid of that line.
No gravity. Incredible. What goes up must keep going up. Oh, I have to restart the game. Okay. Oh, this is good. Oh, but we just keep. Well, this isn't as much. This isn't as much better as I thought it was going to be.
So what if we take out the remove from?
I think we're just gonna. I'm gonna cap the velocities y at 0. So if
you stay in one spot,
velocity.y is greater, is greater than 0. Because remember, higher y values go down. So if velocity.y is greater than 0, then velocity.y equals 0. This, I think, is going to be really nice for testing. Again, characters, we go up, we stop. Oh, this is the best. And we've done it.
That is
okay, fire a laser. Yeah, so it has kind of keep saying.
Wait, what is hitting the platform? Is that the laser?
I think we put that in laser. Yeah. Oh gosh, I had a platform is in the laser.
Okay. So we haven't seen any lasers.
What's your confidence level that this is the right method?
Yeah, like 75%.
So decently high.
I think.
And you were going to say something else as well.
Is it possible? So if it's always shooting in a direction in which it hits a platform, then maybe we don't see it.
The UFO is a platform. The UFO is a platform.
I was going to say, maybe it's just for some reason, the direction in which it's shooting, there's always a UFO is not UFO.
just writing random nonsense. The UFO is a platform. There it is. Okay. Refresh. Let's go. Fly up. Lasers. There we go.
Hey!
And the hitbox was like decently sized. Oh, you know what? It also went away when it hit Sparky. Watch. Oh no, because Sparky's not a platform. So
nope. Sparky's a player.
Sparky was right next to
not in that way.
There we go. Wow, the hitbox is big.
Yeah.
Look at that hitbox.
I think it's because of the size of the sprite, I believe. But I think we can change the size of the hitbox as well.
Interesting. Yeah, that's a really big hitbox.
Yeah.
All right, but we see it working, so that's pretty cool. All right, what are some other ideas? What if we have any other good ideas from the chat on what to implement?
Good question.
We've got about 12 minutes.
Let's see. Here we go. So UFOs are platforms also. Yep, there we go.
All right, put that on screen. Let's give somebody some credit.
So I had switched windows over, so I hadn't missed this chat. UFOs are platforms also. Lasers UFO, it gets removed. Is this expected behavior? No, as you saw right there, it was not expected behavior.
But and very keen eye.
Also,
Lucas, thank you.
Maybe UFO is platform.
Maybe it was.
Yeah.
And therein lies the danger of just hacking random code together. Is every corner that you cut will come back and bite you right in the behind.
Eric, let's see how long the time it takes some answers in the comments. You know, that is my bad. I was supposed to be watching the comments and I was like very deep into why isn't it working? So
incredible.
This is moderator has learned her lesson.
I hope you started your stopwatch.
How long was that, Eric? Let us know in the comments how long that actually did take us.
Yeah. Okay. So yeah, do we have any other? There was someone else had another fun idea.
Comment here. I want detailed video for the code. I'm not able to understand it completely. Are we gonna share this code? Like, so we'll put this maybe in a repo or something and share it with folks.
Well, it definitely. Oh, you mean my?
Yeah, our power up.
Yeah, we certainly could.
Or our enemy, actually.
But Vishal, which I hope I'm saying close to correctly, the Code Lab is definitely the perfect place to get started. I think the different pieces that we're kind of stapling on here will make a lot more sense after going through the Code Lab. That is very much its kind of role, is to make all of this feel, code that you wrote for code that someone else wrote, or code that you were kind of party to pair programming. You always know it's so much better than this existing project that you try to sink your brain into. And the Code Lab kind of recreates that process of having written it yourself. So I think with that, you'll probably feel a lot more comfortable with it.
Yeah, so I'm just pulling up another question that we had on the screen here. So, can't you limit hitboxes to edges of platform?
Yeah, yes. Do you want to try to tidy up the hitbox size?
That could be a good last thing. Yeah, that could be a fun thing to try out here.
Okay, so you mentioned that it could be the size of the image.
Yes, because if you look at the assets in the images, we left quite a bit of like just empty space around outside of it. I'm thinking maybe that's possibly part of the issue there.
Okay.
So we cropped it, I think, a little bit tighter.
Okay. Assets, images, game. All right. So where is a platform? Yeah. Let's see. Like, did I do the same thing? Oh, it's really hard to tell.
I think that's that looks like it's a pretty big. Like there's a lot of white space around it, right? If you open it in open preview, I think you should get.
Maybe just double click that, right? Yeah, ton, yeah. Just a ton. I wonder if it's coming from the laser.
Yeah, so it could be one of the.
Yeah, let's tidy this up. Well, do we think the glow counts? I don't think. Well, we're going to lose the glow if we clip it here. What am I talking about? What am I talking about?
Maybe we'll try that.
Yeah, this is going to make a huge difference. Here I was thinking I needed to blame the platforms. The call.
I mean, I think there's probably a mix of both there.
I just sized the highlight and then didn't save it.
And then didn't crop it.
All right, so we're coming down here. I think this is pretty good. Command K, Command S. Get out of here. Run it back. New asset. We're probably going to need to rebuild the game from scratch.
So I remember, yeah, when Eric and I were working on the game, because we had a lot of white space. The assets that we had just had like a lot of white space, white spacing outside, just because it makes it easier to work with.
I see.
We're like, wait, what is happening?
All right, I feel quite confident that will solve the problem. Oh, we have lost our transparency.
There you go. But
they're clipping a lot.
I think it's so if we can crop that so it has the glow.
Why did we lose? Why does that look so terrible?
Because I think it usually has the glow. And so if you look at the edges here, you can see that's not transparent on the outside. That's yellow. Oh, so I think we'll just have to crop it so that we only have it touches the edge of that transparent yellowish color.
Right. So the issue is that the laser's glow used to fade out naturally. In the asset.
Yes.
So it looked fine.
Yeah.
Right. All right. Can I Command Z my way out of this? I cannot. Luckily, I think I still have the laser on my desktop and will now replace
Truly pair programming.
Okay.
Yes. Truly. You can see the numbers. I'm like, oh, yeah. That is how we pair program.
All right. I think we're going to be back to the
big hitbox.
The giant hitbox. Again, a UFO desert here. We're going to need to get up here. I did have to rebuild the game. Yeah. Anyway, I think that's going to happen. So now this is the more interesting situation anyway, where we resize the hitbox ourselves.
Yeah.
So let's try to do that. And I think that'll be a fun thing to wrap on.
I'm going to quickly plug Eric's comment. Yeah, you can find the code lab at the 17 Days of Flutter website. So that's going to be day 1 is the code lab for building a game with Flutter and Flame. So you can build Doodle Dash and add your own enemy or power up for the Doodle Dash challenge.
Okay, so let's look at the constructor for the rectangle hitbox, which has both a position and a size.
Yep.
And
The size.
Yeah, I think this is basically what we need to do.
Yeah.
And then the position will need to be like centered. So let's see, what is this position parameter? What are you? Position, I'm just following this up. It's a vector 2. Okay. But the position, did it have an anchor as well? I'm going to go back.
It looks like.
There was some other things to close. Rectangle hitbox. There we go. It does have an anchor. Great. Because we're going to put that in the center.
Yep.
In the last episode is not the default. So the anchor is going to be anchor.center. The position, I did not set because I think it's going to inherit the position of the parent.
As a parent. Yep.
When we add it.
Okay.
Hoping. And then the size. This is, I think we basically just guess.
Guess and check.
And check, yeah, exactly. So the size is probably a vector 2. Everything is a vector 2 in Flame. And for our X, it feels like, I don't know, let's try 30 pixels.
Yeah.
And then the Y, it's definitely longer than it is tall. So 15?
Yep.
We'll
see how it goes.
See how it goes. Rebuild. Pick one. Start.
Sparky.
Jump. Okay, here we are. All right. No. The answer is a decisive no.
No. Oh.
It's very wrong.
Hmm.
You were going to say something. Do you have a thought?
How?
Let's get. Okay, this is perfect.
That one.
Oh.
That's. Size equals size divided by 2.
Size equals size divided by 2. What does that mean?
I would go with size, the size 0, so laser would not only hit, but also penetrate the platform a little bit.
So that would basically just mean the absolute center, pixel
of it.
Right.
Yeah.
I'm willing to try that. I'm willing to type basically anything. Okay, refresh. Hopefully size.0 actually doesn't like not exist.
Let's see. And Vinton asked, could the glow be dynamically added? And this was when we were probably cropping the images.
All right, so now it's not doing anything.
Huh.
We didn't get any, it's just flying right through.
Flying right through.
So, all right, let's try one by one. I'm just making everything up right now.
Aren't we all?
I was really surprised by how wrong the last one was, but then also when it went to the left, like nothing was happening. Oh, I wonder if the position is all wrong.
Yeah.
Let's add a position.
Can you try size over 2?
Oh, you know what though? Well, size over 2. Yeah, I don't know really what that means.
Size? Half of, or
this is the size of the laser,
or maybe because it's like the X and Y side, like the size of the icon, and then you divide it by 2. So if you do like size.x divided by 2, and size.y over 2, is that what it is?
I'm going to finish typing this and then ask what you're talking about. I think we were on. No, what is going on with this notifying vector? So size returns a notifying vector, and a notifying vector.
So someone who's on the Flutter account is saying it makes hitbox half the size of the PNG, I think. Okay.
Well, so at this point, size, this variable, though there's some notifying vector nonsense, Where I know we are in the laser. Okay, I agree. Yep, I agree.
Right. So you do like, so vector 2, and then the x would be size dot x over 2, right?
Oh, is that what I needed to say?
Size dot. Yep, x, right? That's the x. And then
but size is just being so weird.
Is that not it? Size?
Well, see, yeah, this is what I'm trying to figure out. So size returns size, which we can just see as a notifying vector 2.
Width. Height and width. There you go. We're just
really
size dot width.
But size is what's upset.
Yeah. Width.
Oh, it's because I'm in the class. I need to put this in unload.
Oh, wait, where are you? Oh, because the hitbox is outside. Okay.
Goodness gracious. Rectangle hitbox. That might not have been right.
All right, I think this is actually going to be where we're going to, if we can get this to work, it'll be a good place to wrap up.
Undefined class rectangle hitbox. What is he talking about?
Rectangle hitbox.
Aren't we just obviously using this right here?
Should be a hitbox.
Oh, I spelled it wrong, I guess. Okay. Never type. Only copy and paste. Never type. Well, let's remind ourselves what we did. So we basically just shrunk the hitbox.
Yep.
Oh, and it's really a quarter. It's a quarter of the size in the center, because half the height and half the width would be a quarter.
Yes. Yeah.
So it'll be a lot smaller. I see what they're getting at now too.
Yeah.
Maybe the number is 3. Maybe it's 4.
Yeah.
Something like that. This is a good idea. Okay. I like this. Chat is coming to the rescue again. Chitty chat chat. Thank you, chat. All right, shoot at.
All right.
I'm hoping this one fires up at us. It keeps.
Oh gosh, it hit a platform.
Did you see it?
It's the print statement came up.
Oh yeah. All right. Yeah.
There you go. Okay, I think that worked.
It went in like the absolute middle of the platform.
Yeah.
That one's not gonna work. Oh, okay. That one kind of clipped it.
Yeah.
All right, this one could be good.
Yeah, because I think the hitbox on the platforms are a little bit bigger too.
Oh, the hitbox.
So it's a little bit wider. So I think we would have to tweak it on both the lasers and the platforms themselves.
I see.
Yeah.
Oh, those ones are just passing right through from the top. So there's something about the platform's hitbox that is also maybe a little funky.
Yeah.
But we see it working on some of them.
Yes.
And Danielle's quite fun idea of and the platform, the trampoline was reacting. That's fun. Look at it. It's just kind of pulsing every time it gets hit by a laser. That's great.
It's absorbing the shock from the lasers.
A completely unintended consequence. When that code was written, you assumed the only thing it could bump into was the player.
Dash, yes. And now we're extending it.
But now there's lasers. Okay. I think this is pretty good. Should we hit some questions to wrap?
Yeah, I think do we have any other questions? Can the laser's hitbox be just a one center point? So I think that's what we were
playing with.
Yeah.
Yeah. But I think we got kind of vaguely close. And obviously if you're making a real game, you'd seriously fine tune it.
Yeah. And then can you limit the hitbox to edges of the platform? Yeah.
Right.
Yeah, that's what we're trying to do there. Cool.
All right.
Yes, Lucas, you did tell us.
You did. Told us so. Okay, Khan, I think we need to make a video of this.
Yes.
And tweet it.
Yes,
that's what we want you all to do.
Yes.
So
#Doodle-challenge.
Yes.
So add your own power up, add your own enemy, and share with us. We'd love to look. And actually, we wanted to plug Flutter Forward, Ask Flutter. So y'all were awesome with questions today. Loved it. Everything, all of your questions. Thank you so much for tuning in and interacting with us. Have more questions you want answers to, go on to Twitter and tweet #AskFlutter. And the wonderful Kate Lovett and John Ryan and a few of our special guests will be answering your questions. So Flutter experts from around the world. So
GDEs that are at the event are going to help as well. And you will scarcely find more knowledgeable Flutter folks than those two. So
yes.
All right, Con, I think we've done it.
We have shooting lasers and collision detection. I think that was everything we had on our
To-do
thumbnail.
list.
So
Yep.
we have checked all the check boxes, I think. So thank you so much for tuning in. Thanks, Craig, for hosting.
Yeah, absolutely.
This is so much fun.
I had fun too. And the next time, we'll see you all in Kenya if you're there. If not, we'll see you on the live stream for Flutter Forward. Until then, have a good one, everybody.
See ya. Bye.